Welcome back, guys. It's your good old friend Take Out a Bank Loan to Go to College Productions, and today we're gonna talk about bases. Whoa! But hey, at least it isn't as bad as that incident. So why do we use bases? Well, Jimmy, it's for a little thing no one cares about called computers. Whoa! Computers use a thing called binary. And you use it to do tasks like yes and no, and yes, and yes, and yes, and no. These numbers are represented by 1 and 0. Or if you really f***ed up, 10. But there's another thing computers like to use called base 8. Or how some people like to call it 8-bit for some goddamn reason. So apparently in math, they want us to do things by hand, even though we have computers that could do this much faster. So here we have 657 base 10, and we're going to convert it to base 2. Because why the hell not? Okay, so you want to start off by dividing the actual number in the regular format by 2. And we do that, we get a remainder of 1 with the actual value of 328. And we repeat this for infinitely many times until we actually consider killing ourselves. And there we are. But oh, don't think we're done yet, Billy Bob. We're only getting started. So we're going to put these numbers right on the side and continue forward. Yay! And there we go. We just add these numbers to the end of the list and we are almost done. And look at that. It's like we're done magically. Wow, it's like computers can read this so we won't have to. Oh wait, that's already a thing. But do we think we're done? No. What we're actually gonna do is write it backwards because why not? And now it's perfect. Wow, wait, we're missing a little something. There we go. Now we're done, and we just ignore this part over here, and wow. Now we have no work to show. It's like a computer. Magical. But you remember that little thing called 8-bit? Well, you're gonna hate it now. So sometimes computers like to go from bases just because they see information's better that way. And for some reason, we're not gonna do it the easy way because we're trying to get depressed over here. But what's that? Numbers and letters? But don't worry, we're gonna do this together and we're gonna love it together because we did it together. Amazing, right? Now we go into our first step where we need to factor our digits into the desired mod number, which is 8 for some reason. We know that 16 equals 8 times 2 because we passed elementary supposedly. Next, what we want to do is multiply the digits to the digits. Yeah, so from here we actually do some math. We could simplify this even more, you know how? Like that. And you know how else we can simplify it? Like that. Great. And you know what doesn't change it? 1. Great. Now let's just do the same thing for F, because we have nothing better to do. Wow. Wow. Wow, wait, what's this? What am I doing? Putting an 8 and a 7 instead of whatever that is. Well, F is 15, my friend. And 15 is the same as 8 plus 7. But why 8? Why are we splitting it in 8? Because the mod number is 8. And I don't tell you how to watch videos, so don't tell me how to math. And wow, when you do more math, you get that. And when you do even more math, you get that. Yay. And well, we're gonna do this again with E. This is actually absolutely nothing. Okay, so we're moving on to factoring out our numbers. So 8 3 times 1, that fancy number we had earlier, gets factored out to 8 cubed over 1. Yeah, that's not how that is, but we're doing that anyways, and we do it again for these numbers. It's black like my soul. And wow, what do we get? We get 8 squared 2 plus 1, which equals 8 squared equals 3. And wow, we do that again for 1. See, we're all having fun here. We're all doing good things to get better with our life. And yeah, so we convert the numbers we got to base 4. I'm sorry, I meant base 8. It's all really irrelevant at this point. That's our answer basically. Good job. You're just gonna put this in the computer, aren't you? Alright, so now we're gonna go from base 8 to base 2, and we could skip actually, we could do step 1, just because you're special. So, we know that 8 equals 2 to the power of 3. And once again, we just add the places that are needed, and just multiply that to the exponent. And wow, we end up with 2 9, 2 6, 2 3, and 2 0. In other words, you're nothing. So next step, we do the exact same thing as the other steps, but differently, until we get that. Wow. Then we do the exact same thing, except we all know that these are 1, so we could basically skip that step and continue forward. So we just write a 1 for every number we have, and there we go, it's converted to base 2. As you can see, my handwriting is getting lazier and lazier. Not because I am getting tired, but because I don't care. So now we have 10 to 16, which is basically going to be one of the easiest things you could do. Yeah. So the way I do it, I just find an exponent value that's close enough to the number without passing it. So in this case, it'll be 16 to the power of 3, which will equal 4096. And we're going to use that as our base. Secondly, we're going to compute the values of all the other exponents under it to get an idea of what we're going to multiply with. What? Multiply? Yes, Jimmy. That's something we're going to be doing a lot. So what we want to do for this step now, we want to try to multiply the higher numbers first to see if we pass the numbers specified. Yay! So we got 16 cubed times 1, which equals 4096, which we showed you already. Now we do it times 2, and whoa, what do you know, it's actually bigger than we thought. So we don't use that, we use this. So now with that as our base, we're gonna be adding a bunch of numbers to it. So 16 times 1 equals 4352, and we're gonna be constantly doing it again until we get a number that surpasses our other number. And wow, would you look at that, we got a number that is too high than the actual number from before. So we don't use that, we use this, and then we use this, and then we do it again. Math. And we're just gonna do the same thing again because it doesn't matter. What? We're using a letter. Well, Jimmy, that's a number, and that number is 10. You could see by the 1 and the. Don't know where I was going with that. Let's just do that. Let's just do that. And let's just do that. See, it was a 10 after all. But now we know that that is the closest number to that. And if you don't know how math works? We're multiplying a number. This number. We're going to be adding 16 to that. That'll be too much. But if you still don't know, we could do it like this. But why are you using beads as the press productions? Well, Jimmy. That represents 11. We have the 1. We have the 1. Don't think about it. And wow, what do you know? This is bigger than that, and is also bigger than that. So we don't use that. We use this. We use 10. And in case you don't know how adding 1 works, that's how it happens. So we use that. So what are our numbers? We have that, that, and that. Oh, thank God we're done. Just kidding, we have more fun stuff to do. Like going back from 2 to 10. Fun. So let's say we have that. Wow. Have no idea what that number is, just made it off the top of my head. But let's see, we have
0, 1, 2, 3, 4, 5, 6, 7.
Wow. So we have 1 to the power 7.
Plus a 2 to the power 5, plus a 2 to the power 4, plus a 2 to the power 2, plus a 2 to the power 1.
And we'll just put that in the calculator and we're done. And we get that. And wow, it's already in base 10. That was much simpler than what we were doing before. Now how about we do that again, but with 16 to 10. Wow. So let's go A, B, C, D, because why not? So
we have 10 times 16 cubed, plus 11 times 16 squared, plus 12 times 16 1, plus pesky little 13.
And what do you know? When we do all the math and we add it all together, we get a 4, 3, 9, 8, 1 to the base of 10. And now we're done. Oh, thank God, we're actually f***ing done!